Good.
Good morning. Good morning, sir.
Yes, good morning, Dr. Jimmy.
Let's humble ourselves for the Lord is word. Father, Lord in heaven, we thank you that you have enabled us, Father, to be among the people to see the light today. We thank you, Father, that you have enabled us, Father, to have such a beautiful morning and such a beautiful lesson, Father, as we've been having as usual, Father. Father, we pray that this lesson may be fruitful to our academics and, Father, and to our overall performance, Father. We call upon your guidance, your spirit that will help us, Father, to master and recall whatever that we are going to learn and whenever that we need it. We call upon your guidance, Father, to guide our teacher. Help us, Father, to be to help us, Father, to help us get and understand whatever that you are going to learn, Father. We dedicate the day into your hands, Father. We have prayed and believed through Jesus Christ who gives me strength. Amen.
Thank you so much, Dr. Jimmy, for the word of prayer. Good morning once again. Thank you so much for joining. Our our lesson today is on derivatives of natural logarithmic functions. So today we are going to look at natural logarithmic functions. So that should be your title for today. Okay, let me hope we are good to start. All right. So what are we going to look at today? So in our lesson today, we are going to look at how do the logarithmic functions look like. We are going to look at the sketch. We are also going to look at the exponential functions and how they are related to the natural logarithms. We are going to deduce the logarithmic derivatives, and then after we shall apply natural logarithms in differentiation. So those are going to be the main areas of concentration in our session today. We are going to start with graphing. How do the graphs of these natural logarithms look like? Now, members, when they talk about a natural log is this one here, that y is equal to the natural log of x. It is ln of x. But as we start, I want you to place for me on your calculator. We are going to draw our table. Like we say that whenever we want to make a sketch to find out how something looks like, always we come up with a sketch. So in our sketch, we are going to have x and we are going to have our y, and our y is going to be the ln of x. But through the chart, members, which value of x should we start with? Let me know and place it in the chat. Which value of x should we start with? So I'm waiting for people to make their, Melinda said 1, -1, 1, -2. Okay, very good. Members have suggested -2, others -1. Now, the first test, can people tell me, if you put ln of -2, what do you get? Put it on your calculator. What are you getting? If you put ln of -2, what does your calculator give you? Math error, math error, math error. Can now people continue placing and tell me at what value of x should we start with such that we don't have a math error? I want you to continue placing. There is a value you're going to reach on whereby you don't get a math error. Even try 0. If some people are suggesting 1. Now I want to bring it to your attention early that natural logarithms, even 0, it is an error. Very good. 0 will give you an error. -2 will give you an error. That means that if we are to get any natural log, we must always start from a value that is above a 0. Natural log can never yield, and you can never have a natural log of a 0, a natural log of negative. That's why when you are reading some books, they will always put here a magnitude. This magnitude is the one that shows you that natural log, the value of x you've put in here cannot be a negative, cannot be a zero, should always be above a zero. So we cannot use a negative. Very good piece. So that's why we always put a magnitude. So whenever you find a magnitude here, that is the meaning that it cannot be a negative. And therefore, as we start here, our values, you are going to allow me that I will start from 0.2. Allow me to start from 0.2 because I can easily get 0.2 here. I can use my 1. I can use my 2, I can use the 3, I can use the 4. Yes, I can use any of those values. Now, when you place your calc, ln of 0.2, my calc will give me a negative 1.6. When I place ln of 1, I'll have my 0. When I place ln of 2, I have my 0.7. Ln of 3, I have my 1.1. Ln of 4, I have my 1.4. Now, we are going to plot these values the way we have obtained them. So the first one is 0.2 and negative 1.6. This is 0.2 is here and negative 1.6 is a point here. This is the point around this point here. It is here. Then I go to the next 1 and 0. 1 and 0 will be here. Then I go to 2 and 0.7. 2 is here. This is 0.2456. 0.7 is here. Then 3 and 1.1. 3 is here. 1.1 is a point here. Then I go to the next one, 4 and 1.4. 4 is here, 1.4 is here. Members, what is the nature of this thing we have plotted? Is it line, curve? I don't know what members are seeing. What are you able to see when you look at our pattern? Zoom is saying a curve. Ayobo, very good. A curve, very good. So members have noticed that we are obtaining a curve. So we are going to draw. And when you are drawing curves, we use our free hand. So I'm going to draw our curve passing through the points we have plotted. Now, that is how our curve will look like. Now, when our curve reaches 0, it does not touch 0. In other words, in mathematical, we call it asymptotic. It does not touch 0, but it just becomes very, very close to 0. And members, this is our curve for y is equal to ln of x. This is how the curve looks like. Now, what do you need to know? Like we have said that these curves do not yield, so don't yield. This is your y and this is your x. You cannot have a natural log of a 0. You cannot have natural log of negative. And therefore, whenever you meet that you have a negative for your x, always we shall put a magnitude such that it can absorb those negatives that we may be having. Okay, so allow me now to check what effects can we have. So when you look here on my screen, I want to uh, let me hope it will accept what I want. Oh, natural log. Okay, okay. Let me. If I wanted to see how I can is equal to ln x. Oh. Not really. I want to y equals to log log. Okay, I'm just trying to so that I can get that log. It can come. So that is how it looks like. I want also to let you know that when we talk about this hope you can see. When you look at your x, it is just there. Then it goes, the way you see it, it goes endlessly, but it does not go through it. When I change here, let me say the values. I want you to check when I put the values. When I put 3, I want you to observe. I have put 3. I want you to observe. Let me put another value. Keep observing. What is the effect of that value when you put it there? What is the effect? Does it bring any effect? Check. I'm putting the value here. I'm putting, when I put, let me say, check out the values I'm putting and tell me which effect you are not seeing. Members, which effect are you not seeing whenever we increase them? Which effect are you not seeing? Can I keep increasing? It moves upwards. The curve extends towards the y-axis. That is very true. For you, I'm increasing the value further. I am increasing the value further. So the moment we keep on increasing, you notice that it just keeps on moving very close to the y-axis. What about when I put a negative? What happens? Let me put for you a negative. Are you seeing what happens when you have a negative there? I continue. I'm putting a negative. You notice the effect of negative. What about when it is negative? Here there is a negative x. How will the curve look like? Now that is how it looks like. In case there is a negative here. In case your values of x are negative, like in case you put negative, negative, that's what happens in case it is in a negative thing. What about when we have a fraction here? What happens? In case I have 1 out of x, how will your curve look like? Your curve will look like that. Hope you are not seeing the difference. In case it is 1 out of x, your graph looks like that. In case here, in case for your x was a negative, then still your curve will look like that. So those are what we call the natural logarithmic curves. So it depends on what you have and then the kind of shape. But the most important, you need to know that we shall always yield the curves. We shall always yield curves. Okay, so I think we can now continue. The calculator, yes, the calculator gives you zeros. And that's why I've told you, we always put the magnitude here. What I'm using is the software that has been embedded. So those things on a calculator, you cannot obtain it. And that's why I'm telling you that if it is a calculator, you always put the magnitude and we shall not have negatives here. Yes. Okay. So we are going to continue and look at how does it relate to natural logarithms. So we are looking at how does the exponential function relate to a natural logarithm. Now, I want also to bring to your attention that our natural log, we write it like y is equal to natural log of x. But like you hear, it is a logarithm. Now, in logarithmic form, we write it like log e of x. Members, these two things, this and this, are the same thing. In this format, I've written it in terms of log. Here, I'm writing it in terms of ln, but these two things are the same, so they can be used interchangeably. They are the same. Now, how can I relate? We are going to relate. Now, if I'm to relate, I know I want to write this statement here in a format of this nature, whereby I'm going to write log e of x is equal to y. It is the same thing. But I want to remind you, when we are looking at logarithms, from your laws of logarithms, there is something you wrote that log a b is equal to c. Members, can you give me the simplified form of this? Put it in the chat. What was the simplified form of log of ab is equal to c? What was your simplified form without logarithms? Very good. Very good. I've seen some answer there in the chat. Yes. So remember, as we said from our logarithm, that this a here comes and it becomes a power here. And therefore you say that your b will always equal to a, then a power c. That you bring this base here and then you just place it to power the c. The same thing here is going to happen, that this e of ours, we are going to apply it and it will come here, and it will power here. And therefore, that means we can say that x is equal to e of power of y. Members, are we still together up to that point? Is that point still fine? Okay, very good, very good. Thank you. Now what did we say? Remember, members, we said that when we are differentiating, I can differentiate individual parts. We had a lesson, and we say that I can differentiate this alone, I can differentiate this. For this part, I'm differentiating with respect to x. For this part here, I'm differentiating with respect to y. So that means I can say when I differentiate x, I'll get 1 dx is equal to, when I differentiate e power y, yesterday we said that once we differentiate natural log, we remain with the same thing. So we shall still have ey, but with respect to y. Now this is the same as 1 dx is equal to e of y but dy. But since I'm interested in finding my dy dx, I'm going to divide this side by ey. I divide this side by ey. So I'll have 1 out of ey dx is equal to dy. But since I want dy dx, I will divide this side by dx, divide this side by dx. And therefore, I'll end up with 1 out of e of y is equal to dy dx, which you can easily write as dy dx is equal to 1 out of ey. Okay, let me first clean and I write it better. So, which we can write as 1 out of, okay, let me write it again here, which you can write as dy dx is equal to 1 out of e of y. But what is e of y? When we come back from here, you can notice that e of y is the same as x. And therefore, I'm going to come here and I say, and therefore, my dy dx is the same as 1 out of the x. And I'm going to say that this is my answer. That whenever I do differentiate dx of the natural log of x, my answer will always be 1 out of x. So this is very, very important. Members, have we understood? Are we on the same page up to that point? Gilbert says yes. Okay, yes. Okay, good. We are safe. Okay, good. Good. Yeah. Okay. Can we take note of it and then we continue? So that is now the kind of general thing we are going to look at. We are going to be rotating around there. Okay, good. So when you finish, you let me know and then we can continue. Okay, people saying we can continue. Okay, people have finished, so we are going to continue. Okay, now we are going to look at the derivative. What is the general rule? Now, members, if I have y is equal to ln of f of x. Now, when I put a magnitude, I've told you that the magnitude means that your function cannot yield a negative. That is the meaning. That's what now I want to bring to your attention. That's why I put it there. Now, but I can ignore it as long as I know what I am doing. Now, what is going to happen? Members, if I say I can let my funct u equals to my function of f of x. Now, if my u is equal to that, I'm going to have my y equals to ln of u. Where there is fx, we put u. Now we have changed the variables. We have u and we have the x. So that means that we are going to use our chain rule and we shall say that our dy dx is equal to our dy du then times our du dx. So that means you need your dy du, you need your du dx. So I'm going to come here and I say, what do I have? Here I will say that my du dx is equal to this function differentiated, which I can write as f prime of x. Now I come back here. Y is equal to ln of u. So y is equal to ln of u. We have already from the first step we had, like where we said that if I have y is equal to ln of x, the moment I get my dy dx, my answer is the same as 1 out of x. Now here we are going to just imply. And if I may ask members in the chat, you tell me, what do we have for what dy du? Which answer shall we have? Put it, very good, very good. Ayobo, good. Gilbert, good. Melissa, good. Yes. So we just select. So here we shall have 1 out of u. So when we come back here, we shall say our dy du is equal to 1 out of u, then times our du dx, which is f prime of x. So members, I can write this as f prime of x out of u, but our u we said is f of x. So this is going to be f of x is equal to dy dx. And now this is the general rule that whenever you have your d of dx of any natural log of any function of f of x, it means that differentiate that function you have, then divide by the original function. That's the meaning. So this is the rule that whenever you are differentiating a natural log, always look at the function you have in this position, differentiate it after divide your answer by the original function. Yes, so that is the rule we are going to be looking at. When you finish, you let me know. But in case you have a question, feel free to ask. Hmm. So let me wait for you to finish and then we continue. Yes, Ayobo, yes, we shall look at that. We are going to look at that, Ayobo, even if it is in that format. Eh, Still, you apply the same. Differentiate that function, divide by the original function. Okay, members are suggesting we can go on. Okay, okay, so we are going to continue and start looking at examples. Now we are going to look at our first example. And our first example, we are going to look at differentiate with respect to x, natural log of 5 of x. Now, still, if they give it in this format and they want you show how you come up with the answer. Don't just wake up, don't just put the thing, but you show how it comes about. So here, in case they have just given you such a number, or you have found it, you say that y is equal to natural log of 5 over x. Then you use the rule. What does the rule tells us? Or how does it come about? Then you say that let your u equals to 5x. And then you will say now, what about my y? My y will equal to ln of u. So here you shall have your du dx equaling to 5. And here we shall have our dy du equals to 1 out of u. And therefore, it means that to obtain our dy dx, we shall have our dy du then times our du dx. So what is our dy du is 1 out of u, then times du dx, which is 5. And therefore, we shall have 5 out of u, but our u is 5 out of x, so we shall have 5 out of 5 of x. And members always reduce, so this would be 1 out of x. And then you stop there. So that's how you show how it comes about. Okay. So I'm going to wait for you and then we continue. Mm. Okay, people have finished. Okay. Uh, what about we have another one? Let me say we have natural log of 2x squared plus 5x plus 1. Still here, you do the same first show. You say that let my y equals to the natural log of 2x squared plus 5x plus 1. Members, always what is in front of the lane, whatever comes here is always your function. So that means here you shall say that my u is the same as 2x squared plus the 5x plus the 1. And what is my y? My y will be now ln of u. So you differentiate. My du dx will equal to, you drop the power, which is going to become now 4 of x plus the 5. When you differentiate a constant, you get 0. And therefore, you have your dy du. Here, this is always automatically to be 1 out of u. And therefore, to get our dy dx, we shall have our dy du, then times our du dx. But what is our dy du? Is 1 out of u. So we shall have 1 out of u, then times du dx, which is 4x plus 5. And therefore, our answer for our dy with respect to x will be 4x plus 5 divided by u, which is 2x squared plus 5x plus 1. Then you end at that point. For functions where you can reduce, you go on and reduce. For functions where you cannot reduce, you leave it the way it is. Any questions? Okay, now can we start a quick one? In the chat, members, what is your answer for this? What is your answer for that? Put it in the chat. I want you now, members, to start recognizing that I just differentiate what I have here. I divide by the original power. Now, that is the quick one. We are not writing in our books, but I want you now to start mastering. Okay, I've seen an answer from Ayob. Okay, thank you, Ayob. I don't know whether members are noticing. Dr. Jimmy. Very good, Melissa. Gilbert, you have forgotten something. Always look at what you have in front of the lane. Look at what you have in front of the lane. Yes. Differentiate it and then you bring. Okay. What about, okay, I've started, now people have started seeing the things. Members, what about this one? What will be our answer? I have put for you another one. Okay, good. Shakila, Melinda, Toshiba, Zio. Yes, those are the answers. What about that one? Hey, what will be your answer? Mm-hmm. Okay, I'm seeing some answers. Now, do not forget that if that answer can be reduced, you have to reduce. Are you seeing the answers you are giving? The differentiation is okay, but now you are forgetting to reduce. Yes, but you have differentiated very well. Melissa, your differentiation is okay. Jim, it's okay. Ayobo, it was okay. The differentiation is okay, but do not forget to reduce. Uh, okay, 3 out of x, 3 out of x. Very good. 3 out of x. Perfect. Yes. So those who are just coming in, differentiate this function, divide by the original function. Good. Okay. Now, this is yours for trying out. Our third example, I have y is equal to ln of ln, I have 5 plus x, everything under a root. Can we also first try it out? Now show the working for this. Show the working for this. Eh, Show the working for this. Now members, you need to know how do we remove the root. You need to know how do we remove the root. Okay, Rose, that's okay. Melissa, Gian, yeah. Can we first try this one? Try. Make sure you show your working for all the steps. Mm. Okay, people have started putting some answers in the chat. Right. Okay. 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 Can we have someone who is going to take us through? Okay. Yes, Ayobo?
Yes, sir, good morning.
Yes, good morning.
So we're going to break that lane function.
Mhm.
We
Mhm.
have u equals to what is inside,
Okay. Mhm.
then y equals to the whole thing, linear.
Okay.
So that u equals to root of 5 plus, that can be written as 5 plus x power a half.
5 plus x power a half. Good.
So to find the du dx, we shall use chain rule.
Mhm.
We drop the half,
A half.
then multiply by 5 plus x. We subtract a half minus 1 to get negative a half.
Okay. Which is negative a half. Good.
Then we come and differentiate what is inside the brackets. We multiply that times
Times
1.
1. Okay. Okay. So we get the same thing. Okay.
Yes.
Mm-hmm.
It can be written as 1 over 2 root 5 plus x.
1 out of 2 root of 5 plus x. Okay, good.
So for dy du,
dy du.
dy du is just 1 out of u.
1 out of u. Mhm.
So our dy dx is dy du multiplied by du dx. So for dy du, we have 1 out of u, and then du dx is 1 over 2 root 5 plus x.
Yeah.
We have 1 over u as root of 5 plus x multiplied by 1 over 2 root 5 plus x.
Mhm.
So the whole thing gives us 1 over 2 into brackets 5 plus x. Yes, that's our dy dx.
Okay, thank you. Thank you. That's correct. Yes, I know some people have gone on to simplify it as 10x plus 2x. Yes, it is very correct. Either this or this, both of them are very. Oh, no, this one doesn't have x. I don't know why I'm putting x. This is 10 plus 2x. All right. Yeah, so that is what we get. Anyone with a challenge, or we are good to go? Very good. Okay, Baswali, you may ask.
Teacher,
Yes,
good morning.
yes.
For me,
Morning.
my du dx, I obtained it as it is 5 plus x power negative half all over 2.
It is very okay. It is very okay. Eh, so, however, when you reach here at this is very okay out of 2. But remember, when you take it down, like when you use the rule that a power negative b is the same as 1 out of ab. So when you have your 5 plus x power negative a half and you apply the indices law, it's the same as having 5 plus x everything power a half. But anything power half is the same as the root of 5 plus x. Okay, so that is okay, but simplify further.
Okay,
Okay.
teacher.
All right. Okay. Uh, I wanted to I wanted to give you more numbers here that we can try out. Okay, allow me to create more space here, and I first give more real numbers. 1, 2, 3. More 3 at least before we start on some word. Okay, we have another one here. Now here, do not forget that our rules will always work. Don't forget. I have y is equal to 2x cubed ln of x. Can we first try out that on our own? Don't forget now, but in the chat first tell me which rule are we using for this? Which rule are we using? Very good, very good. The product rule. Yes, the product rule. Let's apply it. Let's apply it. Just remind those people who have forgotten the product rule. The y, the x is equal to u, the v dx plus your u, the v dx. So let's start the product rule. Thank you. Let's start. First, get what your u is. Oh, instead of this is this. Oh, okay. This is v du dx. Okay. Okay. Mm. Okay, okay. Can we have someone to run us through? Who is coming to run us through? Okay. Yes, Gilbert.
Good morning, sir.
Morning.
Yes, so we begin by first taking our 2x power 3 as our u and our ln x as our v.
Okay, good.
So u equals 2x cubed
Mm-hmm.
and our du dx will equal to 6x squared.
Okay.
So when our v is ln x,
Mm,
and when we differentiate with respect to x, the v dx will equal to 1 out of x.
okay.
So we apply the product rule. So
All right.
u is 2x cubed
2x cubed.
multiplied by the v dx, which is 1 out of x,
Okay.
plus ln x multiplied by 6x squared.
Okay.
So this one will be 2x cubed out of x
Mm-hmm.
plus, that will be the same as 6x squared ln x. Then here when we divide, that x can divide and reduce to 2x squared plus then 6x squared ln x. So we can factorize out the common factors, which is 2x squared, open brackets, that will remain 1 plus 3 ln x.
Okay, thank you, thank you. The answers I'm saying in the chat are very, very okay. Yes, now which answer do I prefer? This answer is very okay, but sometimes what I know, sometimes some of us make a mistake, but the answer is there. So make sure that you don't add, because I know someone here may instead add. Don't add those things because you cannot add them. You cannot add them. Then Zomi, check out the answer. Check out the answer. That answer, something is not adding up. Okay, let me first pick a hand. Yes, Ayopo?
Yes, so that from that part of 2x cubed over x plus
Hmm.
6x, would I be wrong if I wrote just that that's 2x cubed times 1 over x as 2x cubed times ln x?
If you had written
That's 2x cubed.
from here or from
Yeah,
here,
from there, yes. So
as
then as 2x cubed
uh-huh,
ln x.
as your answer
Yeah, for that, but I don't know if it would be right.
for this part here.
Yes.
How are you reaching here? If I may ask, how are you reaching here?
No, I'm not reaching there. I'll just asking just to know.
Not really, because these are different things. What you need to know is that 1 out of x is not the same as ln x.
Oh,
I think this is what we are trying to confuse. Then these are not the same. This rule does not exist. This rule here does not exist.
okay.
Hmm.
Just the derivative of ln x. Okay.
Yes, derivative. Okay, Dr. Jimmy. Hmm.
Master, what if that here where I've written that 3 ln x, what if I
Hmm.
write ln x cubed?
Where?
I write there inside the bracket here at our final answer.
It is okay. Ln x cubed, it is okay.
Okay. And
Hmm.
yeah, that is to prevent adding these two, the one and the three.
Uh-huh. Yes, it is okay. It is okay.
Okay.
Okay. Okay. Uh-huh. Okay. Yeah. Those who are factorizing in form of putting 2 plus 6, here there is still a common factor. So when you are factorizing, you factorize completely. Completely. Okay. We have another one here. Y is equal to ln 2x plus 1 divided by 4x minus 1. Which rule are we going to use? Which rule are we using for this? Quotient. Very good. Quotient rule. Okay, let's start. Let's start. The quotient rule. Very good. Yes. So let's start with our quotient rule and always state it. Don't do it from your head because sometimes you can forget. So state it always. State it before you start using it such that you know how you're going to be following it up. Okay, I know members are doing. How do you know, Joan, that you have to apply a certain rule? Now, Joan, when you find that you are dividing two things, then what has to come to your mind? When you are dividing two things, that is quotient. When you are multiplying two functions, that is product rule. So you need now to know that am we dividing two functions? When you look at what we have here, you notice that this is one thing, so this is like one function. Then this is the second function down. Then you know that that is quotient rule. If you find that you are noticing you are multiplying, then you have to apply the product rule. Okay. Who is ready to take us through? Who is ready to run us through? Okay. Baswali?
Okay, teacher.
Mm-hmm.
So we shall first let our u to be equal to
Our u to be equal to. Baswali,
e
are you the
of
one who took us through the other number?
no, I just asked something, teacher.
Okay. U is equal to
E of 2x plus 1.
ln of 2x plus 1. Okay.
And our du dx will be now equal to
Du dx will equal to
1
mm-hmm.
all over 2x plus 1.
Okay. Have we differentiated well here?
Oh, it will be 1 all over 2.
Okay, we first differentiate here, Baswali. So first differentiate for us this function here. What do you get when you differentiate it?
I get a 2.
You get a 2.
Mm.
Then over
All over 2x plus 1.
2x plus 1. Okay.
And I will let my v to be equal to
Mm-hmm.
4x minus 1.
4x minus 1. Mm-hmm.
And my dv dx will be equal to
Mm-hmm.
4.
Okay.
Now I will apply my rule.
Mm-hmm.
It will be v, but my v, I know that it is 4x minus 1. But I will
Okay.
apply brackets
Mm-hmm.
multiplying with my du dx, which is 2 all over 2x plus 1. Then minus my u, but my u is equal to e of 2x plus 1.
Mm-hmm.
Then dv dx, which is equal to 4. Then all over v squared, which is 4x minus 1 into brackets squared. Then I will be having 8x minus 2 into brackets all over 2x plus 1 minus in minus 4 in of 2x plus 1 all over 4x minus 1 squared.
Mm-hmm. Continue.
Teacher, up, is it okay if I get the LCM?
Yes, yes, yes.
Okay, teacher. I get the LCM there.
Mm-hmm.
So I will be having 8x minus 2
Mm-hmm.
then minus 2x plus 1 into 4 ln of 2x plus 1. Then all over 4x minus 1 squared. I'm start, teacher.
Let's take this one. Like, do you know, like when I have 1 out of A out of B, it's the same as 1 out of A divided by B, which is the same as 1 out of A times 1 out of B, which is 1 out of AB. Not
Yeah.
seeing? So give me
Yes.
this okay, give it to us in a simplified form now. Simplify a bit further.
So I will have 8x minus 2 minus 2x plus 1.
Okay, allow me to start with this.
Okay, teacher.
Mm-hmm.
All over bracket 2x plus 1 multiplying with 4x minus 1 squared.
Okay. Okay. That is okay. We can end there.
Okay,
Thank you,
teacher.
Baswali. So
Okay.
members, you can end at that point. You can end at that point. Okay, let me first speak on. Yes, Jovan.
Good morning, sir.
Morning.
Actually, I've got a problem with the network, but even I've could have come very late, but I can understand everything. But the problem is how to differentiate lean. Just enlighten me more about that, then I can also follow all this because all the steps I understand, but only differentiating that.
Like when you are differentiating lean, you look at what you have here,
Yes,
you differentiate it. Then after, divide by original function. So when you differentiate 2x plus 1, you get 2. Then divide by the original function.
yes.
Okay.
Okay,
That's how we
thank
do
you,
it.
sir.
Okay. Yes, Arnold?
Good morning, sir.
Morning.
So I was inquiring about the first step on top.
This one?
Yes. I thought when you're
Mm.
multiplying, for example, 4 into brackets, ln 2x plus 1, you get like something like 4 ln 2x plus 4.
Oh, now this one is one function. Then multiplied by 4. This 4 multiplies the whole thing.
Yes.
So when I'm writing, I write 4 ln of 2x plus 1. This 4 multiplies everything inside. It's like having log of, let me say, 2, 3, and then you multiply everything by 2. When you are multiplying, you don't just set 2 times 3. You set 2 log of 2, 3, which is the same as log of 2, 3 squared, which is log of 2, 9. But once you multiply 3 times 2, you get 6, which is not right.
Yes.
Is it fine?
Yes, sir. Thank you.
Oh, okay. Dorcas,
Good morning, teacher.
morning.
Teacher, I'm inquiring here. Is it right if I make this negative 4 in the final answer to affect this bracket of 2x plus 1?
It is okay. Though now, even at this point, Dorcas, it is okay even like to write it in this kind of format. This format is a bit better, but if you want to put it inside, it is okay. It remains the same. Though always we prefer something that is factorized further. Even here, instead of having 8x minus 2, someone can just write 2 into 4x minus 1, like in a factorized format.
Thank you, teacher.
Okay, then lastly, Dr. Jimmy.
Now, Master, you say that it is possible to multiply that 4 throughout. Now, what if someone from here, from step 2, what if someone raised it as a power of 2x plus 1?
It is also very fine. And
Now,
you
how
bring
would
the
it?
2 here, and you bring the 4 here.
Yes. Now, how would it affect this one? That 2
No,
plus
no, this
that 2x.
answer, if you write this answer, Dr. Jimmy, 2x plus 1 power 4, and someone who has 8x plus 4, natural log of 2x plus 1, your answers are the same.
Okay. Now,
This
Master,
and this is the same.
now which of the two? Because when they have said that simplify, which of the two is more simplified than the other?
Which one is more simplified than the other? Now here, we may not look at which one is. This one is okay. This one is okay, but also this one is very okay. Both of them are
Okay.
fine. And even you look, depending on the book you read, the moment they reach somewhere here, they stop there. Because all of them yield the same answer.
Okay. Thank you, Master.
Okay. Okay, so members, we can continue. And master Lean. Lean is going to save you a lot when it comes to differentiation. Once you master it very well, you are going to enjoy differentiation. However complicated the function is, as long as you have mastered it. 1 minus 3, 1 plus 2x. We are differentiating that. But now, yes, Ruth.
That was my question. As
Mm.
if what if the bar does not go the bar does that okay. I was going to ask if in is outside and that is what you put on the chalkboard on the board.
Oh, okay, okay, okay. Now, okay, let me start with this. Now, what do you do, members? Remember, the laws of logarithms are going to be very important. We can first remind ourselves. From logarithm, you say that when you have log of a, b plus log of sc, when it is do the same, you say that here we shall go on and multiply. If you have log of AB minus log of SC, you say that this is the same as log of A, B divided by C. Now, the same laws apply to a natural log. Like we say that natural log means log when the base is e, is an exponential. That's what we said, yeah? Or that is, they are the same. So that means that if you find members that I have a log that has been written in this format, then you can take it into this format. Are we together? That in case you find it written in this format, take it in this format. So in natural logs, if I have natural log of A plus natural log of B, this is the same as natural log of A, B, you multiply. The same thing, if I have natural log of A minus natural log of B, it is the same thing as having natural log of A divided by B. Now, if I may ask you, can you first write for me this one here? This one we are going to try out. Can we decompose it from this side and we bring it back here? Because you cannot work it out in this format the way it is, it becomes a bit complicated. So can we bring it back this side and show me what you get? Eh, Aha. Okay. 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 Very good. So that is the first step always you do. Now for such, I do expect that you are going to first write it in a more simplified one. Say y is equal to natural log. And then here you have 1 minus 3x minus natural log of 1 plus 2x. And then this is where you start from to differentiate. And I'm going to encourage that whenever you find yourself that you have a function that has two terms or more than, always put a bracket. Why? So, some of you may make a mistake. Are you seeing? And someone may mistake it that as if it is natural log of 1. More so when you are panicking. So it is always better. Put a bracket to show that this is one thing. Yes, put a bracket to show that this is one thing. So the moment now you write it in this format, members, go on and differentiate. Hope now everyone knows how to differentiate. In fact, people have already gotten the answers. Yeah. Okay. Okay, put the bracket. I think here we can just go and get our answer. So our dy dx is going to be equal to, who wants to tell us the answer you are getting? So you do it in that format and then you get the answer. Okay, yes, Ayobo?
So for that first term, we have -3
-3
over 1 minus 3x minus 2 over 1 plus 2x.
Okay, good.
So we can factor out the -1.
Negative?
We can put everything over common denominator.
Okay.
1 minus 3x, 1 plus 2x. So after we have -3 multiplying the bracket of 1 plus 2x minus 2 multiplying the bracket of 1 minus 3x. So we can open the upper bracket to have -3 minus 2x.
Minus?
6x minus 2 plus 6x over 1 minus 3x multiplying the bracket of 1 plus 2x. So up there we notice -6 zeroing out with +6. So we only have -5 over minus 1 minus 3x multiplying the bracket of 1 plus 2x.
Okay. Thank you. We can stop at that point. Melissa, where did you get 1 minus 37x? Melissa, I don't know where you're getting that one. I don't know whether you have multiplied. Melissa, have you been able to see? Yes, Paswali?
Teacher, like from the question, if I first interpret it in such a way that y is equal to in of, and I read that first bracket that 1 minus 3x, then I multiply it with this one which is down, that 1 plus 2x raised to power of -1.
It is okay.
Now how do I go by that if I write it in such a way?
Now, in such a way, then you'll use this approach. Sorry, you are going to use this. Are you saying? So
Okay,
when you
teacher.
say that y is equal to ln of 1 minus 3x, and then you say 1 plus 2x power -1. Now, in case you are decomposing it, then now for you, write ln of 1 minus 3x, then plus ln of 1 plus 2x, everything power -1. Then when you go back again, you'll have ln of 1 minus 3x. Now this negative, for you to be able to differentiate this one easily, without using the chain rule, you drop the negative. The negative comes here, and then you remain with 1 plus 2x, which then brings you back here.
Oh, teacher, thank you.
All right. Okay. Yes. Now, Melissa, even if you multiply the denominators, the answer you have given is not okay. Even if you multiply those two denominators, you have not multiplied well. Check out how you have multiplied. Then secondly, like I've said, Melissa, always give it in the simplified form. The simplified form is like the what? The decomposed one. But also, you can look very well that these answers you have, if there is any way your answers can be related, mostly in this natural log, you'll find some pattern. Like here you have 1 minus 3x. In your answer, you have 1 minus 3x. You have 1 plus 2x. You have 1 plus 2x. So you better leave it in that format without multiplying. So Melissa, check out even how you have opened the brackets here. Remember, when even you are opening up the brackets, this is not a difference of two squares. So you multiply very, very well. So members, that's how you do such a number. So you are going to find out that they are quite a number. Even if you had, let me say, even if they had given you this, okay, which one do I want? That there are quite a number of things you are going to find out. More so when you master this kind of differentiation, it's going to be very easy for you to differentiate many, many things. Allow me to write here, and then I give you some number. I have y is equal to natural log of x squared sine of x. Now, even when you look at this one, as you can separate it into functions, that this is one function, this is another function. So someone can write this as y is equal to natural log of x squared plus natural log of sine of x. And then you differentiate smoothly. Can you first differentiate that? Let's first differentiate that. So people are trying 2x, okay. 2 out of x cot x, Lilian, Vicky. Okay, okay, that is good. That is good. Yes, Baswali?
Teacher, there I'm getting a 2 or out of x plus cos x.
When you differentiate this, you get 2 what? X out of?
X squared.
Plus differentiate sign, you get?
Cos x.
Out of? Did you do that?
Oh, no. I had forgotten that.
Eh.
But my question is,
Hmm.
I tried to differentiate tan, but I failed to get the correct answer, teacher.
Tan, when you differentiate tan, what do you get?
I get sec squared x, but I just crammed it in that way. I failed to go through the correct procedures.
Oh, can I refer you to lesson number 2? Because
Okay,
we
teacher.
looked at a lesson number 2 of differentiation. We looked at how we differentiate tan from first principles. That's where we looked at those things.
Okay, teacher, thank you.
Okay. Okay, very good. What about members? Okay. Before we reach here, allow me also to create one more. I want now still, because we need to first master this, because even where we can apply it. Allow me to give you another one here. What about when you find something like this? Differentiate with respect to x. They have given you y is equal to x. I know you have seen such numbers whereby they have given you x power of x. As I pick on Abby. Yes, Dorcas?
So that number that you give us,
Uh, I'm not getting you well. You are saying?
that number that you're giving is really important. What is the
Hmm.
so I'm not getting something.
I'm not. We are not putting something.
Not like is this product true?
Where? Here.
Yes,
Here.
yes,
Yes, this is natural log. We are applying the law of logarithms. You know that in log, when I have a b from your logarithm is the same as having log a plus log b. And I've told you natural log is log. So it means that if I have natural log, here I have x squared, I have sine of x. So x squared is like your a and sine squared is like your b. These are two functions which when you can separate. Because when you separate and you go back, this is like addition, you multiply. So I'll multiply this and this, I got back the other one. Have you understood?
yes.
Mm. Okay.
I should always apply like
Yes?
no. So I should always apply
Uh,
no.
I'm not okay getting you well. I don't know. You're a bit far away from your microphone. I'm not picking your voice very well.
Okay, teacher. I'm saying should wouldn't it's us the diversity always apply like
Okay, unfortunately, I'm not picking you, but I'm hearing, should you apply? The thing is, always, if you find that it is product, you are multiplying two things, apply it there. In case it is division, apply it there. And then you apply the laws on how we differentiate.
okay, thank you.
Okay. Okay, we go back. We are here. Now, when you look at this, in the old curriculum, they could give this and they put around 5 marks. So when you look at it at first, you may say, this kind of thing is very what? It's very easy. You may think you may think it is very easy. However, it cannot be as easy as you think before you start it. So what you do is you look at it and then you start working it out. Now, this is where now we can start applying the knowledge of natural log. How do we apply the knowledge of natural log? You remember from your logarithms that if you find a number, let me say 2x is equal to maybe 5. Here you can apply log on both sides. You say, let me apply log of 2x this side. Let me apply log this side. So when you apply a log on both sides, you have not changed anything. The same thing happens here, that you can apply log on both sides. So here I can say this is natural log of y is equal to the natural log of x. Now, when you are in this format, then you remember from your logarithms that this can still be written in form of ln of y is equal to x natural log of x. Then now you can do your differentiation. Now, that's why I told you that you need to learn how to differentiate. Now, when you look at this one is in terms of x. This one is in terms of what? In terms of y. So what are you going to do? Differentiate this in terms of y. Differentiate this in terms of x. So in terms of y here, we shall have 1 out of y, because natural log of y gives you 1 out of y, but I've differentiated with respect to y. Then when you look at this side, This side is a product. You have x, natural log of x. So you remember your product rule that this is my u, this is my v. So that means you are going to have your u as x, your v as ln of x. So that means that your du dx is equal to 1. Your dv dx is equal to 1 out of x. Then you go back in the rule that u du dx plus v, this is what? U dv dx plus v du dx. So you bring your u as your x times dv dx, which is 1 out of x, plus your v, which is ln of x times du dx, which is 1. So where you end up, this and this cancels, so you end up with 1 plus ln of x. That means that when you differentiate this, your answer becomes 1 plus ln of x. So now that means we are going to come back here and say this is 1 plus ln of x. But everything here we have differentiated with respect to x. Now, what are we interested in? We are interested in dy dx. So it means I'm going to say my dy dx is equal to y 1 plus natural log of x. I've taken the y here and I've brought the x this side. But what is my y? My y is x. So here it means I'll have x into 1 plus natural log of x. Or another person can write it as 1 plus ln of x power x. So that is the same thing. You write it in a way you want. So you have to apply. You have to apply. Okay, Fik, that was good. Nalik Santos. Okay. Dr. Jimmy, check out. Members, is this fine? Is this okay? We hope we're on the same page. In case you have a question, you may ask. Yes, Julie?
Morning, sir.
Morning.
So I applied log on how will it work?
If you applied
Log.
log?
Yes. Like log of,
Yeah. Log of?
log of 1 equals to log of x power x.
Where?
Like from the beginning.
Okay, now, Julie, here, log. The log we can apply is called log of where the base is e. So log is the same as natural log. But log when the base is e is the same as natural log. But why here we don't mainly use these logs? It is because when you are writing, sometimes it becomes a bit hard, like writing log ey is equal to log of exx. So you see that it is a bit bulky. But what you need to know that natural log is the same as log of this.
Okay, thank you, sir.
But if you want to use this log thing, you can use it. There's no problem. As long as your answer looks a bit, but we prefer mainly using ln because it's a bit much easier. Okay, good. Let me now put another format. So that is one format. And even members, I want to let you know, let me say they have given you a number, which function. I want to give you some weird function. Let me say they have given you 1 plus x power 2 divided by root of 1 minus x, maybe power 5, something like this. Even when you have these functions, you may not use I know here you are going to say we can use our quotient rule. It is very okay. But now when the stage you have reached, if you can apply your natural log, apply it. So you apply natural log this side, apply natural log this side. 1 plus x. squared out of, here allow me to write 1 minus x power 5. Okay, like that. You can apply it on both sides. Then for you know that this is natural log of y is equal to natural log of 1 plus x squared minus the natural log of, then you put the root 1 minus x power 5. Then you differentiate the way we differentiate. So this is very okay. You end up with the same answer. So you are going to try it on your free time about how you can utilize it. Yes, Ruth.
It's sorry to disturb you, but if I'm given, okay, how does this question be said? Because as introducing natural law, I don't know how the question comes for me to
Oh,
answer. I have to introduce natural law for me to differentiate. It is set as well as equal to what? Is equal to, let me use this way, x to power x. If
like
since
now,
this
how is that now? Like, let me say, Ruth, in case maybe they give us, let me say y is equal to 2 power x. I'm just using this, eh? Now, when you look at this, you notice that there is no any rule that applies. Because what are you differentiating? You are differentiating with respect to x. But now you instead notice that here, x is the power. So you notice that you can't use the product rule, you can't use the quotient rule, you can't use any other rule. Now this is where now you need to think quickly. How can I remove x? Because for you, you cannot differentiate a power of a variable. Even if you had y is equal to, let me say, sine x, then everything power what? X. Still even here, you cannot differentiate this power as long as your variable that you are differentiating with respect to is a power. Then you cannot use this normal way of differentiating. So you first compose this power to be on a linear line for you to be able to do it. I don't know that you are getting it, not yet.
I have
You have understood, eh? So you apply it basing on the question, how the question is said. But like I've said, this natural log is going to be applicable for all the questions you have been doing. Even these questions, let me give you another one. Let me say y is equal to x, x, let me say okay, x into x plus 1, like this one. Even here you can apply this natural log. It can apply very well. Let's just do this. Now you know that if you are to do this, you could either multiply through or you could just, so someone can just say that ln of y is equal to ln of x into x plus 1. Then someone can say, for me, I want to simplify. I say ln of x plus ln of x plus 1 is equal to natural log of y. Then you differentiate. You say this is 1 out of y. dy is equal to this is 1 out of x plus the x plus 1 is 1 out of x plus 1. But I've differentiated with respect to x. Then someone will go on and say now, my dy dx is going to be y into what is 1 out of x. So this one you can see, I'm simplifying it out of x into x plus 1. So what was your y? Well, your y was this. So you notice that someone will remain with his y, which was x plus 1. Then up here, you'll have x plus 1 plus this, which gives us 2x plus 1. Then out of x into x plus 1. These ones cancel. So you remain with your 2x plus 1. So it can apply as long as you master how you can utilize it both on both sides. Hope that is okay. Oh,
that someone that chat raised the question I was going to raise before with
mm,
X. Ayob is asking, would
mm.
someone be able to just use quotient rule there? So
Would someone what?
be wrong to use quotient rule on this other side of the screen. That is
Here.
what I just started calculating. That
Eh,
for example,
no, it is okay. You can use any rule, but I'm saying that there are instances where you are going to reach whereby if you are using the quotient rule, it is going to take you time. It's going to take you time. You are going to find yourself dealing with quite a lot of things. And now for such a case, most so now when you are dealing with the trigonometric functions, you'll find when they have given you, let me say, a trigonometric function in a fraction form, you look at it, you notice that things are going to be very bulky. So for such a case, let me say they can give you exponential of x out of 2, then they give you sine of x, divide by x, or maybe of cos of x. You can use your quotient rule. But you may notice that quotient rule will take you a lot of what? A lot of time. And therefore, for such cases, you say, why don't I apply the natural log on both sides? So you find that here, if you apply the natural log, you just say ex of 2 sine of x minus x, maybe natural log of x cos of x. So you are going to find that when you use the natural log, at one point, things are a bit much easier than depending on the function you have.
So I introduce natural log when I have a variable like power, and also when I'm having trigonometric functions, and also in the quotient, the fraction
Even
is
if it is product rule,
very productive.
even for all the things you have been dealing with in differentiation, you can apply lean and solve them as long as you apply it very well.
Thank you.
So for you just weigh and say, which approach can I use here? And then you apply, depending on what you are dealing with. Okay. Yes, Paul.
Morning, sir.
Morning.
Now, from the question, from the given example, y equals 1 plus x squared divided by root of 1 minus x power 5. Now, sir, according to the given item, mathematically, when we follow first principles, we can see that the rule that works there, it is the quotient rule. Now, can someone be penalized because of changing the item?
No, you cannot be penalized. Why you think it is quotient rule? Because that's what was taught to you at first. But if they had taught you this first, then you would have said it is okay. Now, mathematically, what we are interested in is the mathematics you are working on. Okay. Unless when they have specified that use the quotient rule. But whenever you have a fraction, whenever you have anything, for you mathematically look at which approach makes my work easier. Which approach can I use? Is that fine?
Yes, it's fine.
So any approach can work. It's like when you are solving quadratic equations. You can use any approach of your any approach you want. You can say, let me use the bulldozer, let me use the factorizing, let me use the completing square. In other words, using natural logarithm is like another way of differentiating. It's like another way. However, the one thing that we need always to remember is that don't forget that whenever you are introducing natural log, you introduce it on both sides. You introduce it on both sides. But there are functions that you are going to find that they are not easy to solve if you are not using natural log. You find that you are differentiating, things are becoming more complicated, more. Yes. Okay. Then lastly, Baswali.
Teacher, like if I have in, then when at the same instant, like what was here in blue on the screen, if I have in, I'm multiplying it with again the exponential. Why do I get here?
You are saying, hey, we are going to look at that. That is our next. That's our next.
Okay,
Okay.
teacher, thank you.
Kale. Okay, now let me give you another one. Okay, we are still trying out. We have not yet mastered very well, so we need to. Let me say, you'll find a number of this nature. They have told you 2x squared minus 1. Now, when you look at this, what are you noticing? Your y is the power of an exponential. Now, for such a case, what do? Introduce natural log on both sides. So you'll say natural log of e power y is equal to natural log of 2x squared minus 1. What do you get? Now remember your laws of logarithm, that this power can drop. So you say y natural log of e is equal to ln of 2x squared minus 1. But like I've told you, natural log means log. So when I have ln of e is the same as having log of e, but there is this e. Members from your chart, what is log ee? From your logarithms. Aha, very good. Aha. So this one is equal to 1. So ln of e is a 1. So that means that now your question in a simplified form will be y is equal to natural log of 2x squared minus 1. And now once you are at this point, you differentiate. You say now my dy dx will equal to, I differentiate this, I get my 4x divided by 2x squared minus 1. So that is how you handle such questions. That look at it, you ask which approach can make my y, even when you find those exponentials in your question. But it's going to come with practice. It's going to come whenever we practice, as we keep on practicing. Hope that is okay. Hope that is okay. Are we still on the same page? Lean is like the short form, okay? Yes, Gilbert?
Yes, sir. I'm having just, it's not about this, but like just for knowing, like we write in, why do we call it lean?
Okay, now it depends on your pronunciation, on how you want to write it. But we call it, it is a natural log. So it depends on how you pronounce it. If you can pronounce it as lean, it is okay. But it depends on how you pronounce it.
Okay, sir.
Mm. Okay, so the pronunciation may not matter a lot mathematically, but how you write it is what matters. Okay.
Yeah, but I pronounce it as LN because when I say in, I may write that L as I.
You're saying
For me, I pronounce it as LN because when I say,
LN?
yes,
Hey,
when I
it is
say
okay.
in, yeah.
Mm. Okay, so let me give you one and then we see also how it applies. Take an example. You may find this. Y is equal to 2 exponential x squared plus 1. Hmm. Hmm. Now, okay, let me now maybe throw more light. Now, this lean, the one we are saying, it is like this. L in, something like that. Now, this one is an L, and this one stands for the log. This one stands for natural. If now I can put it like that. That's why I use lean to show you that this is L, meaning log, and this is N, meaning natural. Let me hope now, Gilbert, it is a bit okay. Or you say lean in NA, but as long as you know that it is L, Is it lean or in? Okay, there is no I. There is no I. Like L stands for log. N stands for natural. So natural log. Yes. It would be natural log. Oh, okay. Yes, Ayobo? Okay. So we are trying. Okay, Gilbert is fine now. Okay, okay. So let's try. Yeah, and now when it comes to some of these pronunciations, they originate from somewhere, and now it depends on the country. But even when they are pronouncing it, they pronounce it like this. That's how they pronounce it in. So that's why we use that. But that's how even they write it. Like when you want to pronounce it, you say in. Yeah. Mm. I know you have done some calculations concerning compound interests. You'll find out that you'll apply it in. Mm. Okay, so hope members are trying out. So here you can look at those power things. Those numbers where you have those powers, you'll find that using the net. Okay. Yes, Ruth.
So I went to peruse through it and I think
Okay.
I'm good.
Okay, it is well. Mm-hmm.
We introduce natural log on both sides.
Natural log on both sides. Okay. Mm-hmm.
And we start differentiating, but on this other side,
Mm-hmm.
the right there
Mm-hmm.
is we consider certain law whatever product. So since it's
Mm-hmm.
two exponential,
Mm-hmm.
so first on this side, I will I'm going to use product rule.
Where
Is
this
this
side?
no. Okay, Shami, I've not choose product rule, but okay, this side. Let's first do this side. 1 out of y dy.
Mm-hmm.
Now what I've done on this side is I got the value of I split. Let's first split.
Uh-huh.
Natural
Now that one, we can't do it at the same step. We first split.
okay.
Uh-huh. So natural log of 2
Okay. That's what I did. I don't know if it's correct.
plus
Plus natural log of exponential x. Yeah,
yeah,
that's what I did. If it's
that
right.
is very correct. That's very correct.
But the plus sign, you put +1 on the power.
Plus here. Okay. I was saying here. Okay.
That's
Now, let me now write it using the permanent mark. Okay. So that is okay. Ln of y is equal to ln of 2 plus ln of e x squared plus 1. Can you even first simplify it further?
which it's on the right hand side.
Yes, simplify it further before we differentiate.
Which idea?
Simplify for me this side.
Okay, even I don't me I got the value of lean 2. I don't know if that's right.
Okay, what I wanted you here, Ruth, I want you to tell me if I have log of A power B, in which
Yeah,
other way can I write that?
it's
When you drop
it's
the power.
b log
Uh-huh.
s log base
Uh-huh.
of
Uh-huh. Can you apply the same at this step here? Plus,
So I go that step where I skip because me I just came up with x squared plus 1 direct.
X squared plus 1. Then natural log of E. Are you not seeing? And then what is natural log of E?
It's 1.
1. So you have ln of 2 plus, here better put a bracket because you may mix something like that. Now you can differentiate for us.
Okay, 1 out of y dy
1 out of y dy
is equal to 0.6931 for the side term.
remember you are differentiating. When you differentiate ln 2, what do you get?
When I differentiate into I get okay. I get 0. Is it?
0. Good. We continue the other side.
Then when differentiating, that's 2x.
2x. With respect to x.
To then this side we cross the y this side, and so we remain with dy dx is equal to 2 is equal to y is 2.
Okay, we substitute 2x, then your y is
2
2
exponent power x power 2 plus 1, which is 4x exponential x power 2 plus 1.
Thank you.
Thank you, teacher.
Yes. So that's how you navigate it. So you start slowly. Anyone that is lost on this, sometimes you need to simplify quite a bit. Otherwise, things may. Don't even now on that number. I know someone could say, why don't I go and use the chain rule? The chain rule can as well work on that number. For you, it depends on which approach. You look at the number, then say, which approach can I use? Can I use the chain rule or no? So someone who knows how to use the chain rule could have used it as well, whereby you say, my y is equal to 2e power u. Then you say, my u is the same as x squared plus 1. Then you say, my du dx is equal to 2x. Then my y is equal to 2e power u. When I differentiate the y, the u, from yesterday's session, you end up with 2eu. And therefore, you'll come and I say, chain rule, you multiply the things. So you say my dy dx is equal to dy du, then times du dx. So your dy du is 2e of u, then times your du, which is 2x. So this gives you 4x e power u, but your u is x squared plus 1. And then you say this is 4x e power x squared plus 1. Now it is going to come with practice for you to choose which method should I use. Should I use chain rule? Should I introduce log? So it depends on the number. But the beauty is whatever approach you use, at the end of the day, you'll get the same answer. Are we good, members? On that, are we still on the same page? And we proceed? Yeah. So the more practice we shall make, the more things will become very clear and easier, because you have to be knowing which approach to use here. Okay, let's look at some mini scenarios now. They have given us the equation of that curve, and they're asking us what could be the exact coordinates of the stationary point on this curve, and determine whether it is maximum or minimum. So, do you want to first try it? Why not? Why not? First try it and we see. But I'm going to give you a few minutes as you try it. At least first get for me your dy dx. At least first get it. Get it. Okay. Let me send some greetings to Biguli SS. Yes. Thank you for joining. I don't know whether the Gavanians are around. This is Gavin. Gavin. Mans Gavin. In fact, let me. Okay. I don't know which name they are using. I wanted them to come on. Biguli SS, which name are you using? I want to find you. I want to stress you. Okay. Yes, Biguli SS, get for us one or two people to take us through how we get at least the dy dx of this. One person can take us through how we can get the dy dx from Biguli SS. I want to get Biguli. Yes, Biguli, you can unmute.
Good morning, sir.
Yes, good morning. You take us through how we can go about this to get our dy dx.
We have our expression as in x over x. Then we can say we can let it in x to be.
Okay. So which rule are you using?
Quotient rule.
Quotient rule. Okay. So what is your u?
X.
Lin x.
Then du dx is 1 out of x.
1 out of x. Good.
Then my v is x.
dv
dx is 1.
dv dx is equal to 1. Okay.
Can apply the quotient rule that dy dx is equal to v du dx minus u dv dx over v squared. And it becomes x divided. It becomes x times 1 out of x minus ln x times 1.
Okay.
Out of x squared.
Okay.
It becomes 1 minus ln x out of x squared.
X squared. Okay. Thank you. Get for us a girl to give us any girl to take us through or to first briefly tell us about stationary points and what do we do to get that stationary point. Yes? Yes.
Now at maximum, y dx is equivalent to 0.
Okay, good. So there we say at stationary points, or in order for us to get the stationary points, our dy dx is equal to 0. Thank you. We continue.
Now 0 will be equal to 1 minus ln x out of x squared.
Okay.
Was multiply 0 by both sides. X squared. 0 times x squared, that is 0. Then equaling to 1 minus ln x into 1 minus ln x into x squared.
Okay, okay. I had cancelled them. I don't know whether you saw it. Like you are multiplying both sides by x squared. This is what you are saying, right?
Yes.
Okay. Okay. We can continue.
Now from there, ln x equals to 1.
Equals to 1. Very good. Ln x is equal to 1.
We divide by 1,
Okay. Now, okay. Now, before at that point, can you first bring in your log? Like we said, natural log is the same as log. So when you are solving and reach this point, that's when you bring in your log for you to be able to get x. Is that fine? So we are going to write it as log e x equals to 1.
x equals
1
to e power 1.
E power 1. And what is anything to power 1?
Anything to power 1 is 0. That number.
That number. Okay, good. So this is E. Thank you. Now, remember we want a coordinate. We want a point. So we are going to get also the Y point. So to get the Y point, we go back to our original, which was ln of X out of X. Are you continuing to take us through?
We substitute that e. Our x, we substitute the value of x, which is either x.
So what shall we have?
In e divided by e.
So what is ln e?
That is 1
Out of?
out of e.
Okay, thank you. Now you get for us either a boy or a girl to tell us how do we get the nature of these points. So members here, our coordinate will be E, 1 out of E. Now class, what you do when you are at this point, E is a value. E can give you a value. But because you want to be very accurate, leave your E there. Much as E can give you a value itself. It can give you E, you get a value. But you leave it at that point. Don't go and say, I'm going to place my decimal. You leave it at that. Have you gotten a boy? Or a girl? Okay, let me hope the rest were on the same page. Because they wanted us to get the coordinates of the stationary points. At stationary points, we know that dy dx is equal to 0. Now, this is the coordinate on this curve. So now we want to determine what is the nature. Is it maximum or minimum? And when we are looking out for the nature of any coordinate, there you have two approaches you can use. Those who know the graphical approach, you can use the graphical approach. Those who know the the getting the second derivative, you can use the second derivative. So it is up to you to use which one you want. So people are saying we find the second derivative. Okay.
Max, when we want to prove if it is maximum or minimum, we shall get the 2y of the x.
Okay.
So from what we had got first, our dy dx was 1 minus ln x over x squared. Then we can still use the quotient rule there and say that our u is 1 minus ln x. Then du dx is negative 1 out of x. Then we say our v is equal to x squared. Then our v dx is equal to x. When we substitute in the quotient rule, 2y of dx will be equal to our v, which is x squared. Then times negative 1 out of x minus our u, which is 1 minus ln x times x times 2x.
Okay.
Then out of x power 4.
Okay.
That one becomes negative x minus 2x into 1 minus ln x out of x power 4. Then that one can be our negative x can be negative x minus 2x.
Negative x,
minus 2x, then plus 2x ln x ln x by x power 4. And from there it can be negative 3x plus 2x ln x out of x power 4. There maybe we can reduce the x and it becomes negative 3 plus 2 ln x by x cubed.
Okay.
Then we can pick our x coordinate and substitute it there.
Okay. Negative 3.
Ln of e out of e cubed. Then it can be negative 3 plus 2. Like 3 plus 2 over e cubed, which is negative 1 over e cubed.
Which answer do you get?
I'm getting negative 0.0497.
Negative
0.0497.
0.04, negative 0.0497. Okay,
So from there we see that our point, since our d2y dx squared is a negative, shall conclude that our curve is our stationary point is a minimum point.
Okay, what are the conditions? Now we need to know the conditions. When you look at this value is negative, meaning that if it is negative, it is a value less than 0. So what is the condition for less than 0?
For less than 0, it is a maximum point.
It is maximum point. So what could be your conclusion now?
Is that our stationary point is a maximum point.
Very good. Very good. Okay, thank you. And thank you, teacher. Thank you, teacher Collins. Okay. So, anyone with a question on that? Hey, anyone with a question on that? Which other, even the second approach, members, even that second approach can work very well. The second approach of using the table, whereby you get your table, and now in your table, you get your dy dx. You get to know the nature. So what you do for this second approach, when you look at our value, we have our value of x, which is e. And now e of 1, E of 1 is the same as 2.718. That means that we get a value less than 2.718. And now for my case, I can get a value, let me say I get 1. Get a value above this. Let me say you have got a value like 3. Feed it here. This was 1 minus ln of x out of x squared. So when you put in 1, you'll find that 1 minus ln of 1 divided by 1. Here you get an answer. You get 1 when you put in 1, which is a positive. Then here it is a 0. So here there is no problem. It is a 0 when you put the actual value. Then when you come and you put a value greater than, which is like 3, you'll have 1 minus ln of 3 divided by that value, and you end up with a negative here. When you put in a value above this actual value, it is negative. So you know that a positive gradient goes up. Here it will be straight, then here it will be down. And this is what we call a maximum point. So you could as well use that approach when you want to find the nature. Here, is it necessary to factorize completely? No, it may not be necessary. But as long as you substitute in very well your values. Ayobo, minimum means, a minimum is this. A minimum, you get a curve of this nature. This is what we call a minimum. Maximum is this. Hey, hope Ayobo that is okay. It is a maxima. It's a maxima. Yes. Now, do not forget these two conditions. If you decide to use second derivative, whenever you have less than 0 is a maximum. You have greater than 0, it is a minimum. Now people who are getting errors on the calculator, you don't just put E. Remember we said this was E1. E1 means what? E1 means and then E1. So what you do when you are placing this, put the 1, don't just place E. You say E1. Now for this one where you said E3, you say E1 power 3. Place it well like that on the calculator. Yes, Ruth?
Okay, this is not cat sketching, but for curve sketching too, they usually advise to use second derivative. If your intercepts are 0, 0, so what if, okay, I'm requesting, for this and I didn't hear properly, this other green work, this second derivative, they tell us that it can give you wrong answers at a certain point, especially when you do not know that your curve has intercepts of 0, 0. If as a question can be set like that and it's this plane and they just want us to find stationary points, but then secretly the intercepts are 0, 0.
So, okay, come again. I've not yet gotten what you wanted.
The question is, can they set for us such a question? This the screen that it intercept. Of course, for here you cannot trace them, but that its intercepts are what? 0, 0. Now for me, I go direct to getting the stationary points as we have done and trying to find the nature of the curve without me finding the intercepts. So for example, if in this question secretly the intercepts are 0, 0 and I get my values from the second derivative, yet I am how can I say it? Okay. I failed to phrase the question properly, but that is my argument about the disadvantage of second derivative.
Okay. Now, what happens? I think what is happening, it depends on the nature of the function you are dealing with. An example of that function, the nature of the function, now like Ruth you are mentioning, whereby you cannot use the second derivative. Let me clean my screen. I'll explain back this green thing again. Now, the nature of that curve you are talking about, take an example. In case you have y is equal to x power 4, you note that for such, if you are to use the second derivative, you cannot be able to get the what? The answer. Reason being is that for this one, its intercept is 0, 0, which I agree with you. So here you cannot say that I'm going to use the second derivative to get my answer, because when you differentiate the first time, you'll end up with 4x power 3. You differentiate the second time, the squared the x, you'll get your 12x squared. Now you notice that here, when you are trying to get your second derivative, you are getting 0. So you cannot use the second derivative to make a conclusion. So because now that one, in other words, whenever you find that for your second derivative, the moment you put in 0, you get 0, then it means that you cannot use that one. You cannot use that approach to find whether it is a maximum or whether it is a minimum. Is that fine? Yes. So for you, if you look at your second derivative and you are getting when you put in 0, you get 0. It means that for such a function, you cannot obtain its second. You cannot use the second derivative, that approach of the second derivative, to get its whether it is maximum or minimum. Because when you look at, however, for such, that's where now it is always better. If you know this approach here, you use this approach of the table whereby you get your dy dx. Then when you get your dy dx, when you look at this actually, you can notice that your value here, still when you are solving, you are going to get a value of 0. When you solve here, you say that 4x cubed is equal to 0. So you notice that your x is equal to 0. Meaning that when you get a value less than 0, say you get negative, maybe negative 1 as my value. Get a value above 0, say you get maybe 1 or 2. So when you substitute here, you notice that when you put negative 1, you get a value that is negative. When you get a value above 1, you get a value that is positive. So you notice that your curve is coming like this. Yes, so now this is a minimum, of which here you cannot conclude if you had obtained your second derivative. So whenever you are trying to use the second derivative and you notice that your f prime prime x, or when you substitute when you put in a 0, you get 0. Then that one, you cannot find the curvature. We call it, there is no curvature. I don't know whether it is okay or not yet.
It's okay.
It's
So
okay.
teacher, when I calculate the calculating,
Uh-huh.
but
You're saying?
I'm sorry for taking you so much cut sketching, but according to that question, now that you brought it, is it possible for me to think called it's called regional what? Regional this where they tell you to show that that curve does not lie between certain real values. So just in case I have now natural log, am I able to use that method? There is another method of getting turning points that's not this one, whereby you do what you use a b squared minus 4ac and stuff like that. Is it
Less than
possible?
0. Is it
The one
possible?
is for me to apply that, to apply
Okay, now,
that.
when it comes to a more complicated, there is a concept we shall look at. It is in curve sketching. Where we are going to deal with those ones, where you learn more about that kind of thing, how you test it, because there is something else we look at. But that one now is going to come in curve sketching too, when you have such functions. But even at this level of yours, you may not have curves or curves of natural logs that are very, very complicated to that extent.
So that
But
means I can't do the other region of restriction thing when I have natural log.
like what? Like the region of restriction when you have natural log, can we?
Yes, I'm asking.
Your network.
My question is, can I
Mm.
use the region of restriction, like whatever that region of restriction method, when I have my curve stated with natural logs in it?
Yes, you can. You can obtain that region when you are working with a natural log as well. Eh, I don't know that is okay or not. Oh, Ruth, is it fine when you want to find the limits? Okay. Let me hope it is okay. Yeah. Why? Okay. I hope Medicite is okay. Uh-huh. Laws of curve sketching. In Dagile Sharifa, that one should be squared, eh? D squared y, dx squared. Okay, I have seen what Ruth was meaning. That whenever you get the first derivative is degree 1, meaning the second will have no x. I think she's meaning z. Okay, point of inflection. Okay. Okay. That is curve sketching. Yeah, we shall look at that further curve sketching. That one comes after differentiation. No, okay, it is under differentiation too, but that comes after you have looked at the Maclaurin's theorem. That's where we shall look at those things of asymptotes, points of inflection, how to go about it. That one will come in that second curve sketching and how those curves look like. But one of the curves you look at, you will know that now here the curve doesn't touch, the curve doesn't lie in that region. Yeah, that one is going to come in curve sketching too. Okay, can you take a screenshot of this? I think our time is up. Take a screenshot of this. You are going to try out these numbers. Okay, hope you are finished. Okay, take a screenshot. Okay, take a screenshot of these ones. These ones, like we said, you may not do all, but pick out a few and then you test out yourself. Okay, take a screenshot of these ones. So we have looked at number 8, so you can try out number 7, number 6. And number 10, try out those ones. Hoping people have finished. Okay. Take screenshot of the answers you are supposed to come up with. Okay. Okay, even these ones. Even these ones. Okay. Hope members have finished. Then the last ones here. And then those ones are enough. Try out as many. And do not forget here that also we did with those trigonometry things. Okay, I think that is enough for today. We shall continue from there when we meet. Sorry, not tomorrow. Not tomorrow. I think those ones, not tomorrow. Tomorrow is weekend. Okay.